All right, here's an example of a graph, and we're going to draw the line of best fit, and then we're going to calculate or find the equation of the line in slope-intercept form. So this is an example to help you when you get to either the guided practice or the not guided practice. I have the guided steps here, the same steps you have on the guided practice, which will be the same steps you'll use when you get to non-guiding practice. These just help you, it guides you through how to do the problem. Okay, so this is just a random graph. It's not one that you have, but just to see an example. I already drew the line of best fit in here. So this red line that I have, I drew that in there. You may have looked at your graph and had yours just a little bit different, but it should be at least very similar to mine because of how strong this correlation is. It's not much of a difference. Maybe you drew yours a little bit more like down this way or something. But as long as it follows those couple of guidelines that are on your notes there, you have a good line of best fit. Okay, so that was the first step, is just draw the line of best fit, make sure it follows the guidelines. Check. Number 2 says you're going to find 2 coordinates that are on your line. They do not have to be data points. You need to make sure, though, that those coordinate points are pretty exact as possible on the line, and making sure when you pick coordinate points, you accurately pick where they cross nicely. So if I look real quick, if I picked this point, yeah, that's great, it's on 40, but I don't know what the y value is there, so I don't want to pick this point. Same thing if I come down here. 2 issues with this one. One, that point is not actually right on my line. So it's really close. If you needed to use it, you could, but we'd like to find 2 better points. The other issue is, well, I don't know the exact x value. Yeah, it looks right about 90, and you know, if we needed to, we could estimate that, but we're going to try and find better points. Okay, so I'm going to look at this one right here, that my line goes right through, and it crosses nicely at a nice xy value. So I'm going to use that one. It is at x being 60 and y being 800. So number 2, I'm going to write those down. I have a coordinate point 60, 800. And then I'm going to go and find another one. So I just look at each of my crosses and find when I have one nicely. My line's not quite on that point. It's not quite on that point. Doesn't cross nicely. It's not quite on that point. Doesn't cross nicely. I've used this one. Doesn't cross nicely. There's another good one. So notice that there's not a data point there. I can still use it. So I'm going to like put a little open circle here to remind myself I'm using that point, because that point is in fact on my line. So I can use the point 20 and then 1,100. As you get into better practice and you've done this a little bit longer, you don't necessarily have to write down the points you use, but I would definitely circle them or something. So maybe you want to also circle this other point we're going to use. That way you remember what 2 points you're using. Okay. Number 3 says we're going to find the slope using those 2 points. Okay, I know you're going to look at a graph and you're going to say, oh, let's count rise over run. Well, the issue with that is, look at your scale. You're not counting by 1. So I don't go up 1, up 2, up 3. I'm not going up by 1. And I'm not going over by 1. And they're not even the same scale on the left and on the bottom. So you can't even say, oh, I'm going up 100 and over 100. You're not. So you just should not count rise over run, because you're going to count it wrong, and then that's going to be an issue. So instead, the whole reason of picking these 2 points is to use your slope formula. Remember, y2 minus y1, all divided by x2 minus x1. So that's why we picked these 2 points, so we can fill in our slope formula. So I'm going to take my second y value, 1,100, minus my first y value, 800, all divided by my second x value, which is 20, minus my first x value, which was 60. Then I'm going to do my calculations. On the top here, I get 300. And on the bottom, I get negative 40. Then from here, you want to make sure you reduce your fraction. So I get 15 over negative 2. Remember, that's the same as negative 15 over positive 2, or putting a negative out front and having negative and then 15 over 2. So there's my slope. This is very important. You want to make sure you reduce your slope. You also want to make sure that your slope is the correct sign. So I have a negative slope, and I want to go back and look at my graph. Is my graph negative? Yes, it is. So you want to take that some time and check to make sure it works. Okay, so that's my slope. I'm going to use that in a moment. Number 4, it says pick one of those points that you used from number 2. This should say from, not form. So pick one of the points from number 2. So I'm going to go back up here. I'm going to pick one. It does not matter. Pick one. Pick your favorite. Pick the first one. Whatever. I'm going to pick 6,800. I personally am choosing this one. Just, I don't know, smaller number here. I don't know. It was first. Doesn't really matter why. That's all I do there. Just pick that one. I'm going to use this from now on. I don't care about this one anymore. I only needed it to find my slope. Now number 5 says we're going to use the slope from number 3 and the point we picked at number 4 to fill in point slope form that you just learned about, which is y minus y1 equals mx minus x1. And right now all we need to do is fill in our y1, our m, and our x1. So I need this point and my slope. So I'm going to have y. I look at my y value, it's 800, so I'm going to have y minus 800 equals, m stands for slope, which I have here, my negative 15 over 2, parentheses x, and then my x value is 60, so minus 60. Now that this is filled in, go down to just the last thing, just convert it to slope-intercept form. So you learned how to do that in the last lesson. Distribute, and then add or subtract this y value depending on if it's positive or negative. So I'm going to start with my distributing. So I have y minus 800 is equal to negative 15 over 2x plus 450. So I distributed this negative 15 over 2 to both. So negative 15 over 2 times x is negative 15 over 2x, and negative 15 over 2 times negative 60 gave me my positive 450. Now you just got to do the last step. I have a minus 800, so I'm going to add 800 to both sides. I add it to my constant here on the right side so that those cancel out. Leave my y alone, bring it down, equals negative 15 over 2x, and then I just combine those, gives me plus 1,250. And there's my equation. I'm done. So anytime I ask you to find the equation, those are essentially all the steps you're going to have to do. Some of these steps you're going to be able to either do them in your head, or like I said, when you pick these points, you can just kind of circle them. You don't necessarily have to write them down, but I would mark them somewhere, especially as we're going to grade your quizzes or whatever. It makes it more easily available for us to find where your points are, what your points you used, to make sure if that's a mistake you had. One thing you do want to do when you're done, you want to check to make sure once again that slope matched. So I have a negative, and my graph is in fact negative, so that's good. And you want to make sure that this y-intercept is at least mostly accurate. Like, you're not going to be able to find exactly, but make sure that this 1,250 is roughly where your y-intercept crosses. So I'm going to come back up here, look at my y-axis, and notice I am about halfway between my 1,200 and 1,300. So 1,250 would be a very good estimation of my y-intercept. So there's my equation, and I'm done. Now you try yours on your own and rewatch this video to help you do your steps if you need help.